we shall also look at, that is mass, and I shall also look at the density. So this topic will enable you to answer questions when it also comes to other physics lessons or other physics topics, that is on volume, mass, and density. So beginning by looking at the volume, volume is usually defined as the amount of space. This is the amount of space. The amount of space occupied by matter. This is the amount of space occupied by matter, and the SI unit of volume is cubic meters. This is the SI unit. So how do we describe volume, or which figure are you supposed to see before you discuss volume? Assume that you have a container full of water. So this container, once it is full of water in that manner, we shall take up an object that floats partially. For example, let's say a sphere in that manner. So this sphere will displace a given amount of water here. So the amount of water that is being displaced is leaving a space. Thus, it is giving us that space you're talking about, that this is the amount of space which is occupied by matter. So the space which is occupied by this ball here gives us its volume. On looking at now the calculation of volume, or the comparison of volume, I want to look at how to calculate the volume of different shapes, because we already know that the formula for calculating volume is given by base area times height. What is the base? Base means the area that the object uses to rest. For example, if I draw a sphere here, or if I draw a cylinder in that manner, so you'll find out that this cylinder rests from this surface. Therefore, this is its base area. Then this height means the perpendicular height. Perpendicular height means the height should be 90 degrees from the center. So from the center of this cylinder, you measure 90 degrees up to the top. So that gives you the perpendicular height. So in any object or any figure that you are given, volume should be given by taking the perpendicular distance and multiplying by height. If it is a cuboid in that manner, then this cuboid appears like that. So it rests on that surface. That is the surface in which this cube rests. Therefore, this is its base area, and therefore this is the height. So if you want to calculate the volume, the base is in form of a rectangle. Therefore, the rectangle area is given by length times width, and then multiplied by the perpendicular height, meaning that this is the base area multiplied by its height. If I take you back to now the cylinder that we have here, the base area is in form of a circle. Therefore, the area of a circle is pi r squared multiplied by the perpendicular height. So this gives you the volume of this cylinder. So when calculating any figure, maybe it's a pyramid, it can be a prism, for you to get the volume, just use that is the base area times height. We can also calculate the volume of irregular shapes. And you already know that on calculating the volume of irregular shape, we usually use the Eureka cans. So I'll demonstrate here the use of a Eureka can when determining the volume of an irregular shape. So a Eureka can is usually a container that has a spout. I know you don't know what a spout is, so this is what we call a spout. So when you have this container with a spout, I know you've used the kettle. The kettle is also one of the containers that has a spout. So what we normally do, take the measuring cylinder and place it here below the spout. Once you place it below the spout, ensure that you pour water up to that level or up to the maximum level and be allowed to flow through the spout. So at this point, when you pour water and it flows through the spout, water reaches that level. So if you want to determine the volume of irregular shape, let's say it is the volume of a stone. So what are you going to do? You take that stone, if that is a stone, an irregular shape, Then you tie it using a string, and then you hold it. Assume this is your hand. You hold it with your hand in that manner, and then you lower it in water. Once you lower this irregular shape in water, it is going to displace a certain amount of water so that it occupies a given space from the definition of volume. So this stone will occupy a given space, and that space will be equivalent to the amount of water which is displaced. Remember that the measuring cylinder is usually calibrated, and because the measuring cylinder is calibrated, you can read the volume of this irregular shape by the water which is displaced here. So that is how you can be able to determine the volume of an irregular shape. Apart from looking at that is the volume of an irregular shape, I want us to look at how we can be able to compare the units of volume. And here I'm going to use a very simple experiment on comparing the units of volume. I draw a cube. So if this is a cube, I want us to be able to look at it. So if this is a cube, this cube measures 1 centimeters by 1, let us say 1 meter by 1 meter by 1 meter. So that the length of this cube is 1 meter, the width is 1 meter, and the perpendicular height is also 1 meter. Calculating the volume of this cube, it will be given by length times width times height in that manner. So that the volume is given by 1 meter times 1 meter times 1 meter. So what are you going to get here? Yes, Aquaria? Aquaria, if you multiply 1 meter by 1 meter by 1 meter, what will you get?
1 meter cubic.
Yes, get 1 cubic meters. So meaning that the volume of this cube is 1 meter cubic. Then on the other hand, after we've calculated the volume of this cube and found out that it is 1 meter cube, we are going to draw the same cube, but now change its measurement. So the same cube, I'm transferring it here. So when we have the same cube transferred at this point, so that this is the same cube that we had, but now I want us to record the measurements in centimeters. So what will be the measurements in centimeters? Favor? Favor, are you getting me? Okay, Sim says network is still connecting. So if we had this cube, the length of this cube is 1 meter, the width is 1 meter, and the height is also 1 meter. We shall come here and say 1 meter is equivalent to 100 centimeters. Therefore, if 1 meter is equivalent to 100 centimeters, the length of this cube will be 100 centimeters, the width will be 100 centimeters, and the height will also be 100 centimeters. So meaning that we have not changed the size of this cube. What we have been able to change is only the units of measurement. So this cube and this one, they're just equal in size. We have not changed the shape. We have only changed the units on measurement, whereby we have converted this 1 meter, 1 meter, and 1 meter to 100 centimeters, 100 centimeters, and 100 centimeters. Therefore, I want us to get this volume here. Volume will be given by length times width times height. So that our volume here is given by 100 centimeters times 100 centimeters times 100 centimeters. So if you multiply 100 by 100 by 100, I'm going to get, this is 1 million cubic centimeters. So I want you to compare the two volumes of the cubes. The first cube, these two cubes, as we have said, they have the same length, they have the same width, and they have the same heights. But we have changed the units here are in meters and the units here are in centimeters. We have been able to determine the volume of both the cubes. And after determining the volume of both the cubes, we find out that the volume of this cube in meters, it is 1 cubic meters. And the volume of the same cube in centimeters, it is giving us 1 million cubic centimeters. So from here, we can be able to prove that 1 cubic meter is equivalent to 1 million cubic centimeters. 1 cubic meters is equivalent to 1 million cubic centimeters. That is from the 2 cubes. So on writing this 1 million, sometimes you can find out that you take a lot of time writing this, and therefore you can choose to write this number in standard form. And in this case, you'll say that 1 cubic meter is equivalent to 1.0 times 10 raised to power 6 cubic centimeters. So this is the relationship in volume between cubic meters and cubic centimeters. So before you continue, maybe if I can get any question, favor. Favor, are you getting me? Okay, if Favor cannot yet be able to connect, before we go to another thing, maybe Aquaria, do you have any question on the same?
No.
No question, that's good. So that is what entails volume. So we have looked at how we can be able to calculate volume, how we can be able to measure the volumes of both regular shapes and irregular shapes. And finally, we looked at the relationship between volume in cubic meters and in cubic centimeters. So finally, I want us to finish by to look at now the mass. So when we look at mass, at this point is usually defined as the quantity of matter. It is the quantity of matter in an object. And the SI unit is usually in kilograms. This is the quantity of matter in an object, and the SI unit is in kilogram. So matter usually falls under 2 categories. Remember that in physics, we have the basic physical quantities and the derived quantities. So mass is a basic physical quantity. Why? Because it has a measuring instrument, and the measuring instrument for measuring mass is called a beam balance. The beam balance. This is the measuring instrument that is used to measure mass. And that is why we say mass is a basic physical quantities. What are basic physical quantities? These are quantities that can be obtained from any other physical quantities. One of the characteristics of the basic physical quantities is that they can be measured directly using the measuring instrument. For example, time is also another example of a basic physical quantities. Because time is usually measured, can be measured using a stopwatch directly. Mass is a basic physical quantity. We can measure it using a beam balance. So when you look at your mathematical table, we usually have 7 basic physical quantities. 7 basic physical quantities. Among them includes the electric current, time, the mass. These are the quantities which can be measured directly using the measuring instrument. But when you look at volume, volume is not a basic physical quantity. It is called a derived quantity. Why do we call volume a derived quantity? Because these are quantities which can be obtained either by division or multiplication of basic physical quantities. And you could be able to see that when you are calculating volume, we had to use a given formula. If it was a cuboid, it was length times width times height. Therefore, all quantities that need either division or multiplication of other basic physical quantities are known as derived quantities. So you should be able to distinguish between the two. So this is about mass, the quantity of matter in an object. it is measured using a beam balance. Mass enables us to calculate weight. By having mass, you can be able to calculate weight because the weight of an object is calculated by mass times the force of gravity. The weight of an object is calculated by mass times the force of gravity, which is usually written F is equals to mg. So the F here is the weight of an object. So you cannot be able to get the weight if you don't have the mass. And then you should also be able to know that weight usually acts in a given direction. For example, if there is a person who wants to measure weight, this person will have to stand on the weighing balance or on the spring balance so that the spring balance here records the weight of this person. Why is it that you're standing on this spring balance instead of putting it on top of your head? We're standing on top of it because weight usually has the direction, and the direction of weight is usually downwards. So when you stand, your weight is recorded below your feet. And that is why at this point when you have weight, weight is called a vector quantity. Why is it called a vector quantity? Because vector quantities have both magnitude and direction. So you can be able to see weight as direction. And does it have magnitude? Yes. The other name for magnitude is the size. You can be able to measure weight. For example, here, you can say the weight of this person is 290 newtons, meaning that weight has magnitude and it also has direction. Therefore, at this point, we say that weight is a vector quantity. So that is what is usually discussed under mass. And finally, I'll finish by looking at the density. So on description of density of a material, for you to be able to get the density of a material, first you need to know that density is usually written using that sign. This sign is known as rho. Rho is just a sign that represents the density of a material. And the density usually calculated by taking mass over volume. So we have already looked at what mass is, and we have already looked at what volume is. Therefore, the definition of density comes from mass and volume. That density is the mass per unit volume of a substance. Density is the mass per unit volume of a substance. Therefore, how can you be able to summarize this formula? You write it as rho is equals to m over v. Rho is equivalent to m over v. That density is the mass per unit volume of a substance. So that gives you the definition of what density is. After looking at the definition of the density, how can you be able to compare the density of a material? We have two materials here. I can say this is air and this is water. This is air and this is water. So I want us to compare the two densities between the density of air and the density of water. So as we know that matter is usually made up of very small particles. And if we draw the particles in matter here, you can be able to see that for air, the particles are far much apart from each other, but for water, they are a little bit closer in that manner. So when you compare the two, that is air and water, you want to look at which one has a higher density than the other. So the simple description of density, you take one particle, for example, that is one particle there, and we also pick this one as another one particle there. Then we measure the weight of this particle, and we also measure the weight of this particle. Which particle is likely to be heavier? You'll find out that the air particle is lighter, and at this point, the water particle appears to be heavier. So when the water particle here, one water particle will appear to be heavier than one air particle. So this proves to us that the density of water is higher and the density of air is lower. meaning that if you want to get the density, you take the weight of one particle. And this can also be described when you go to the river to fetch water. First, when you carry that container without water, it has air inside. It is very light. But when you come back, it has water inside. It is very heavy, meaning that the density of water is higher than compared to that density of air. So that is how you can be able to compare the density of a material. Usually, you can also measure the density using the density bottle. And the description of measuring density using the density bottle has also been described, that is in measurement 1 in form 1, that apart from calculating density using mass over volume, you can be able to get the density of a substance by using the density bottle. The density bottle does not measure this density directly, because you have to take the mass of the density bottle and divide it by the volume of the density bottle. So take the mass of the density bottle when full of water and the volume of the density bottle. When you divide the two, this is going to give you the density of water. Finally, I want to give you the density of water, that somebody had a container in form of a cube in that manner. So when you have a container in form of a cube in that manner, this container was filled with water. The container measures 1 meter by 1 meter by 1 meter. So the volume of this container was found to be 1 meter cubed. We have already calculated this. Then the weight of this cube was measured using a spring balance. Its weight was found to be 1 gram. Therefore, calculating the density is okay. It's the mass. The mass was measured and the mass was found to be 1 gram. Given that the density is given by mass over volume, then the mass here is 1 gram and the volume is 1 cubic centimeters. Therefore, the density of water was found to be 1 gram per cubic centimeters. So this is how the density of water was determined, because most of you might be wondering how was the density of water discovered. It was by measuring the mass of this container, which was full of water. Then the mass of this water was found to be 1 gram in a container whose volume was 1 cubic centimeters. And that is why we have the density of water being equivalent to 1 gram per cubic centimeters. So reaching at that point, tomorrow I shall be able to prove for you that 1 gram per cubic centimeters can also be measured as 1,000 kgs per cubic meters. That is what we shall be doing tomorrow. But before I get to the end of the lesson, maybe I can get a question, favor.
No question.
Okay, no question. So thank you so much for being part of the lesson. I don't know if we still have Aquaria. Aquaria, are you there? Okay, so we shall be able to proceed tomorrow from where we left today. But for now, let me wish you a very nice afternoon.